Today is a really good day because I'm going to show you how to solve a system using matrices. Now, the reason that's great news is because we know how to work with matrices on the computer using Desmos. So if you put those ideas together, we're going to learn how to solve a system using Desmos. Yeah, actually, it's a really slick concept. It's going to make quick work of some tough problems. But hey, it's not going to be a secret anymore. We're going to figure this out today. And it's part of Algebra 2, so it's definitely something you want to learn. Now, at least for today, one more time, we're going to solve a system kind of the old-fashioned way. So to make sure that you understand this, we've got a system. Remember, you can solve this with substitution or elimination. Honestly, elimination is probably the easiest thing because we're just one step away from having opposites. That's right, you just want your x, your y, and your 8 to all get multiplied by -1. Of course, now the y's are opposites, and if you just add these equations together, you get x equals 7. So that's, x equals -7. And then once you know that x equals -7, you can probably just plug that back in pretty simply. You can plug it back in for either one of these x's, but you take your pick. Going to get your y value. That comes out to be positive 15. Now, that was pretty easy, but still, I want to show you how this system, let me get rid of the extra stuff, this system that we just solved can be thought of as a matrix equation. So we're going to first have to realize that a simple matrix equation of the form matrix A times matrix X will equal matrix B. That equation, that simple matrix equation, actually connects directly to the system that we just had, because matrix A, you'll find out, that's going to be considered the coefficient matrix. It's going to be the coefficient matrix. Now, the coefficients, remember, those are the numbers in front of the variables. Now, matrix X, that's going to be the variable matrix. And don't worry, I'll show you how this relates to the system we just solved. You will like this. There's only one set of numbers that are left. Those will be the numbers that the equation equals. We call those constants. So matrix B will be the constant matrix. Now, let's make sure that you fully understand what we're talking about. Let's set up matrix A. Let's set up matrix A. It's going to be the coefficients. Now, the coefficients would be the numbers in front of the variables. And I'm going to highlight them in blue just so you're sure that we're all looking at the same four numbers, 1, 1, 2, 1. That's going to be matrix A. It's called the coefficient matrix. Now, matrix X is the variable matrix. The variables, it's not a trick question, the variables are x and y. And we always want to make sure that we use the same order that we see them in. So x comes first, then y. And of course, that's the same way in the second equation, x then y. So that means that my variable matrix will be the matrix that contains x and y. Now, there's one more matrix. It's going to be the constant matrix. And the constant matrix is going to be the numbers that the system equals. That's going to be these two numbers, 8 and 1. In fact, we'll be able to put them in exactly the same way over here as matrix B. Now, what we have is a matrix equation. What we want to do is we want to solve this matrix equation. And it's real simple. It always gets solved the same way because every equation is always going to be of the form AX equals B. And all you have to do to solve an equation like this is to do what's called the inverse. The inverse of matrix A to both sides. We will do the inverse to both sides. Now, what's really happening here is we get a cancellation, which just gives us X. Keep in mind that we're trying to solve for x, and then that's going to equal A inverse times B. Now, this statement that I just wrote right here, is actually the most important part of today. So let me say it again. A inverse times B. And if you're like, what's that? Well, that's x. And x is going to be our answers, specifically our variables. So all we got to do is on Desmos type in A inverse times B. Well, almost. We still have to type in the original matrix A and B, but then, like I said, we're going to type A inverse times B. Let's go to Desmos. What you want to do on your computer, most likely, is go to, remember, desmos.com/matrix. Desmos.com/matrix. Maybe you already have that bookmarked. And this is our magic little place. We're going to have to, make a new matrix. That will automatically be called matrix A, so I don't need to actually type the letter A. But it's going to contain 1. Oops, I didn't want to hit that back button. It's going to contain 1, 1, 2, and 1. So we got matrix A typed in. Now, you also have to type in matrix B, but matrix B only needs to have 1 column, so please make it a 2 by 1 so that you can type in 8 and 1. Now, kids, it doesn't get much easier than this. You see, all we got to do is type in that magic formula. What's the magic formula? A inverse times B. So we're going to type that A inverse times B into Desmos, and we'll watch and be ready to be amazed. Remember, to type A inverse, you actually have to type A, then the little -1 sign, and then B. A inverse times B. And what do we get? Look over there on the right-hand side. -7 and 15. -7 and 15. Those were the same answers that we got for our system. That's because that's how this works. When you get -7 and 15, which I would write down here, but when you get -7 and 15, that's your variables. That's your x and your y. And that's why you came to class today, so that we could learn about A inverse times B. Now, let's do a few more problems. What we can do is we can kind of get a little more fancy. We can mix some things around. But hey, you've got matrices now. You've got Desmos. And we'll be able to make quick work of this problem. Listen, this system looks a little bit out of order, doesn't it? Yeah. That means we need to kind of organize it. Now, honestly, the first equation's already organized. It's x, it's y, all as well. But the second equation, you should feel like that this -2x really should be added over here. And of course, when you add it over, it becomes a positive 2x. I still have 3y equals 9. Now it looks better. Now let's be honest, you should be able to solve this system without using matrices. But today we want to solve it using matrices. So the first thing we want to do is we want to set up matrix A. Now matrix A is going to be the coefficients. You don't necessarily have to rewrite them. I just want to make sure that we're all looking at the same numbers, 1, 1, 2, 3. It's that easy. That's your matrix A. Matrix B is your constants. And it only ends up being a column matrix. It's a column matrix that contains 4 and 9. Now, what I'm doing here is the minimum amount of work that you would need to do. That is, you need to still show matrix A and B. Like, you got to rewrite them. I'm not going to make you show the formula every time, but since it's only our second time, as a little reminder, we have to do A inverse times B. I keep saying that because that's something you want to remember. So back to Desmos. And if you'd like, you can hit the clear or the clear all button. And you can basically type in your new matrices that contain what again? 1, 1, 1, 1, 2, and 3. And then we can type in a B matrix, remember it's got to be 2 rows, 1 column, so we can type in 4 and 9. Make sure you don't miss this part. What part? That's right. A inverse times B, and bam, you get your answers. Looks like x equals 3 and y equals 1. X equals 3 and y equals 1. Now, I still want you to say that you understand what those two numbers are. Don't just write the two numbers down in a column and just kind of recopy them. Instead, go ahead and tell me that x equals 3 and y equals 1. Well, really, the whole purpose, or you might say that the real reason that we just learned this idea with matrices is so we can handle a big system like this. Remember solving these just a little while ago? We had to crunch through all the algebra. But, well, honestly, we've got the power of matrices. And if everything's already organized, you can almost see right away your A matrix. Do you see it? It's going to be the coefficients of all of those x, y's, and z's. Almost too easy, isn't it? Now make sure that you keep, but that you interpret -1 as what's in front of, it looks like both of these z's. Again, make sure you keep the negative sign. And then your B matrix is just going to be the constants. Looks like all of those are negative, but in any case, be careful. Always be careful that you're just grabbing those numbers correctly. So there we go. I know this works whether you're solving for x and y, whether you're solving for x, y, and z. It's pretty slick. It's matrices, or I should say it's systems solved with matrices. Now you're going to want to make your matrix a little bigger, right? You're going to want to make it a 3 by 3. Hopefully you're typing these numbers in a little faster than me. If you're using your computer, almost too easy. I'm trying to do this on an iPad. Looks like I still mistyped a number there, which brings up a good point. Imagine that I tried to solve this problem with 71, leaving the number 71 in that spot. Certainly, I'm not going to get the right answers, but I am going to get answers as if it was supposed to be a 71. In other words, the computer's only going to do what I tell it to do. But I don't want it to be 71, so I'm going to fix it. But always be careful that you're just typing the numbers right. Sometimes kids will tell me what I do wrong, and I'll say, did you type the numbers in right? Usually that's the mistake. There they are, x, y, and z. Now, by the way, the reason that's x, y, and z is because that's the order that your equations are in. It's always going to come out in the same order that you set up. So if the first number is x and the next coefficient's y and the last coefficient z, then my answer is going to come out x, y, z. And that's what I want you to do. I want you to say accordingly what you found, x equals, y equals, z equals. Now on the back of your little half sheet, there's a few more problems. This is a little bit of like a practice, something simple that you're going to do. Looks like I don't have the back of my sheet handy, but I want to point out, I believe it's in, what do we got here? It's in problem 4. So if you kind of skip down the problem 4 that's on the back of your sheet, you should feel like that you have a missing variable. It's in the middle equation. You should feel like you have a missing variable. Well, what's really missing is the coefficient. What I mean is the number that is in front of the letter y. What are we talking about? We're talking about a 0. Kids, when a variable is missing, you fill it in with a placeholder. Again, with the number 0. So be careful about that. when you get to problem number 4. Honestly, there's some other things to be careful about when you get to problem 4, but I'm going to let you kind of work those items out. By the way, one more thing about number 4, the answers do come out to be decimals. So no big deal. It doesn't mean you did it wrong, but let's see if you can still get the correct decimals as you practice number 4, as well as the rest of the problems on the back.